all. Let's start with our today's DSA journey with this amazing visualizer by ChaiCode.com, that is at dsa.chaicode.com. Okay, use this link to get a 7-day free trial. Let's start with our DSA. Okay, so and today is this question: merge to sorted list. Merge to sorted linked list into one sorted list by splicing their node together its head. Okay, so it is given 1 2 4 1 3 4. Okay, so this is our question: march to sorted list. Let's take the pen. 1 2 4. So 1 2, oh nice, 2 2 4, 1 2 4, and let's suppose change the color. 1 3 4, 1 3 4, and now we have to mm, merge these two lists. So how could we merge? 1, let's take 1. Now this one from this gray color. Okay, now 2, because 2 is smaller, 2 is smaller, 2. Now 3 from this gray, 3. Now 4 from this black. Okay, 4 from this black, and okay, yeah. Now 4 from this gray. Okay, this is the sorted list. We have to return this head. So suppose we are given head h1 here, h h1 here, also h2 here. We have to return this h, this new, have to return this new head, which represent this new list. Okay, so how could we actually do it? So let's take, okay, let's take this list. Now let's take this list. Okay, so it is 1 2 and 4, 1 2 and 4. Okay, suppose just store this 1, this 1 2 4, then 1, let's take it, 1 3 4 in an array. If we store it in an array, if we store it in an array, what is the sorting? 1 1 2 3 4. So this is the sorted array. Now using this array value, just build the list. Using this array value, just build a linked list. Okay, we can perform this kind of operation, like we take this list, we traverse both lists, then store the all of the value into an array, then sort that array, then just build a new linked list on that value. So it is a long way. Okay, this is also our solution where we collect and sort. I don't write this solution, so see, vals, all values of both lists, sort the vals, reveal the list from the vals. Okay, so this is the point. Merge two sorted list into one sorted list lays you a dump every value into an array and sort it. Collect all the values, then sort. Collect, but it throws away fact that every input is already sorted. And this is our solution. Okay, so big of n plus m into log of n plus m. Now let's move to our optimized two pointer approach. Okay, let's move to our optimized two pointers approach. Okay, So what this approach is, both lists are sorted. Okay, we are given sorted list. Okay, we are given sorted list. So the next node of the answer is always smaller of two current hits. Walk a pointer down each list and splice the similar one. A dummy head removes the edge cases. Okay, how could we do this? Let's take this. Take this list. Or I am not changing any color. I just go with this blue. Okay, I am go with this blue, not changing any color. This is our head. This is the head. Okay, this is also the head. We take a dummy node. Okay, we take a dummy node, or let's say, okay, let me actually making space for it. It will be easier. Make space in between them. So our pointer here, another pointer, let's suppose q. Q is, let's suppose R. P and R two pointers. Both are at the starting. Both are at the starting of that, both of the list. Okay. The list is sorted. Okay. So suppose for these cases, one and one same. Okay. Just, or rather, just give a minute. So P and Q both are two pointers. These are two pointers. So okay. Now P and Q, P and Q. Okay. Which is smaller? Both are equal, so we can take the P1. Okay. So put P1. Okay. And now increase the P. P and Q, which is smaller one? This one. Just put this one. Increase the Q. 2 and 3, which is smaller? This 2. So just add 2 here and increase the P. Okay. And now 3 and 4, which is smaller? This 3. Just 3. Now increase the Q. 4 and 4, which is smaller? 4. P and Q. Let's go P out of the bound. Q. Only Q left. So just put Q. Only Q left. Okay. So just put 4. So this is our list. This is the list. So using two pointers approach, we can easily do this question. Okay. Let's solve it. Okay. Or let's animate it. We have two heads. Put one here, one here, then two, then 3 and 4, which is smaller? 3. 4 and 4, which is smaller? Both of the 4. Let's write down. Mm, we are given two heads, and yeah, so let's try with the function. Function, we are given two list. Given two list. So let's make a dummy. Let's make a dummy node, which is a node. Let's make a tail. We just pointed to this dummy. Okay. Now What is the two pointers logic? While list 1 and list 2. It simply means while both of the both of the list are present. Okay, both of the lists are present. When both of the lists are present and we don't compute anything, we just check every value of everything. Okay, so if the list 1 value greater than the list 2 value, okay, if this is possible, then the merge list, we are creating that merge list using this tail. Okay, so tail, so we are actually taking the tail. Okay, tail is now our current CURL which we actually using previous time. Okay, so the next element of tail is simply list 2 because list 2 is smaller. Okay, so now increase the list 2. Increase the 2 is nothing but list 2 next. It simply goes to the next element. It simply goes to the next element. And now else if list 2 is smaller. Okay, so in if condition we check if list 2 is smaller. In else condition we check if list 1 is smaller. So for this, at the tail or at the end, insert the list 1. Okay, insert the list 1. Insert the list 1 and simply increase the list 1 to the new value. Okay. So traverse it. So list 1 uh, is equal to list 1 next is simply, and also here list 2 equal to list 2 next. This two lines are just for traversing the list. Okay, just for traversing the list. And inside this while loop, okay, every time you have to increase the tail. So just increase the tail, don't increase the tail. So at the end, just increase the tail. Sorry guys, a little bit interruption happens. Okay, so if both of the lists are present, while like till both of the lists are present, and when any of the list is, so suppose in this condition when we are at last you in inserting this 4. So okay, let's go to pen. 5, then 6. Suppose this is our list. So the list is sorted. Okay, so when the p is out of bound for this one, so we don't need to parse it. We just need to put this whole thing at last this. Okay, we can do this. So let me explain it. Let's suppose this is our actual list. Okay, now we have to enter the 2 goes the 4. Okay, so now it is on 3. So what should we insert? We should insert 3 here. We insert 3 here, and now we increase our queue. So now 4 and 4. So we can easily insert this 4 from the P. So when you insert 4 from the P goes end. Okay, so this list, is ending. So now P at null. So this list is ending, but we have these 3 options. Okay, now the question is why it should always become sorted, because both of the lists are sorted, so easily the remaining list is actually the greater one. So we can easily put 4, then again 1 4, then 5 5, then 6. So we have to just put 4, 5, 6 like that, one by one. One by one, 4, 5, 6 like that. Just put it. So for that reason, we just simply say tail is equal to, sorry, tail next, not tail, tail next. So the next element will be the least one or the least two, which is remaining. Okay, so it's nothing but attach the remaining, attach the remaining, and at the end return the dummy next. Let's evaluate it. Okay, we nailed it. Now let's go to the solution and solve it. Our pseudocode is simple. This is our pseudocode. Okay, let's write down it. So first we have to create a dummy node. Okay, let's create a dummy node and initialize with it a null. Okay, and create another node which is nothing but tail, which is pointing towards this dummy node. Tail list one is not equal to null. Okay, and list 2 is not equal to null. You have to check, like, if the list 1 value, the current value, actually list 1 and list 2 is the head of the two linked list. So list 1 value is, if it is greater than, sorry, 2 value, then simply add it after the tail. So the tail next, so the tail next is the tail next we are adding this list 2. So okay, just give me a minute. Disturbance, to a lot of disturbance. So then simply in list 2. So here list 2 one is nothing but head of the two linked list. So just increase it to the next, and in the else at the tail just add the list 1. Okay, and then list 1, increase the list 1 to the next, increase the list 1. Okay, now at the tail, or increase the tail, tail equal to, or tail next, tail next. Okay, and tail equal to tail next, it simply increase our tail. Now if list 1 not equal to null, okay, tail next is simply list 1. Just put it, don't worry. And else means simply list 2 not equal to null, then simply tail next is nothing but list 2, and at the end create a new node which is nothing but head. Let's note star head is nothing but dummy. Next, and simply delete dummy and return that head. Let's run it. Runtime error. Okay. We have to create a node, not null. Okay. List node. Initialize with 0. Now it should work. Yes. Let's submit it. Yes. We had actually easily done it. It is big of n plus m time complexity because we traverse the both list. Okay. So it is big of n plus, and n and m are the size of those two lists. Okay, and no space. So this is our time and space complexity. This is the question march to sorted list. Go use this platform. Use this link. This one. Okay, this link. Use this link. Use it. Go use it. Get a 7-day free trial. Use it. Now, thank you. Thank you very much. Use this platform.